Okay, in this video, we're going to be doing Calc AB problem set number 128. The problems and a playlist are in the description below. Let's see what we're doing. All right, so if R of H is at 1 over 32 quantity 4 plus H squared, I don't know why I didn't distribute that, with H between 0 and 4, I'm going to find the average value of R of H on the interval. Okay, so average value is integral divided by interval, so we're going to go 0 to 4. R of H, which is 1 over 32, 4 plus H squared, dH, all over 4 minus 0, so that'll be 1/4, and then pull out the 1/32, 1 over 32, and then reverse the power rule, so 4H plus 1/3 H cubed, and we are going from 0 to 4, so when we sub in, we're going to get 1 over 128, you get 16 plus 64 over 3 when you plug in 4. When you plug in 0, you just get 0, so that zeroes out. And then I just use a calculator to do this because just a problem set. Didn't want to spend my time doing arithmetic. All right. On the next one, I even less wanted to do arithmetic. So we want to find the volume of the solid formed when R of H is revolved about the H axis. So H is the independent variable, so this is like a normal volume problem. So we're just going to do pi, the integral of the radius squared. So it's going to be pi, the integral from 0 to 4, R of H, which is quantity 1 over 32, quantity 4 plus H squared, and then squared. And then dH. Okay, so we got to square this thing. I'm not looking to square 32 in this video, so I'm just going to say it's pi over 32 squared. And then I have to expand this. It's the only way I'm going to be able to integrate it. So 16 plus 8H squared plus H to the 4th. We're going to reverse the power rule and fundamental theorem this thing. So pi over 32 squared. There's a lot of simplifying you can do, but it'll be 16H plus 8/3 H cubed plus 1/5 H to the 5th. We're going to plug in 4. The nice thing is when you plug in 0, it just zeroes it out. So really we're just plugging in 0 and 4, but we're really just going to get the result of plugging in 4. We get this. So 64 plus 8/3 times 64. Plus 1/5, 4 to the 5th. And you know what? This is practice. On the AP exam, you could leave this, so I'm going to leave it right there. I don't want to deal with it. I did use a calculator on it. I don't remember what it was like 103 over 204 pi or something like that. I don't really remember, but maybe that's right. All right, let's take a look at the next question. Given that probably would be better. Given that dy dx equals 5x plus 3y, find the values of m and b if y equals mx plus b is a solution to the differential equation. So this is a really good question. I love this question. I'm going to do it two different ways. The first way, I'm just going to look at what dy dx looks like in two different ways. So here, if y is mx plus b, then dy dx is definitely m, right? So also, y is equal to mx plus b, and there's a y in the differential equation, right? So one version of dy dx is m. The other version is 5x plus 3 times whatever y is. 5x plus 3 times the quantity mx plus b, right? So I'm just finding dy dx two different ways and setting them equal. I see from this that the right-hand side has like x's and constant terms, like an x term and a constant term. On the left-hand side, I just have m. So I'm going to make it 0x so that I can better compare these things. And I will factor the right-hand side. So 5 plus 3mx plus 3b. All right, if these things are equal, then the coefficients of x are equal, meaning this equals this, or 5 plus 3m is equal to 0, which tells us that m is negative 5/3. And the constant terms must be equal. So m must equal 3b, which means that b is 1/3 of m, which means that b should be negative 5/9. Those are your values of m and b. So that's by finding dy dx two different ways, setting it equal, and comparing coefficients. It's a very good way of doing it. Another way to do it in this particular case is that you look at it and our solution is linear, and linear functions have a second derivative that is always 0, right? So if you know that the second derivative is 0, what we can do is take dy dx, find the second derivative, so I'm going to do that. So using 5x plus 3y, it's going to be 5 plus 3 dy dx. So I'm going to substitute 5x plus 3y for dy dx. So I'm exploiting the fact that the solution is linear. This method would only work on a linear solution, but it will work. So this dy dx is 5x plus 3y. Just take any linear function and find its second derivative. You will get 0, right? So I do know that this second derivative that I'm finding must be equal to 0. So 0 should be equal to 5 plus 15x plus 9y. And if I just rearrange this, solve for y, to put it in mx plus b form, I get negative 5/3 x minus 5/9. This is a great way to do this particular type of problem, and it's a very common problem to do like the linear solution. The other method of equating coefficients will work more generally on more types of solutions, but have this kind of in your back pocket because you might run into it. So here we again are getting negative 5/3 and negative 5/9. All right, let's take a look at one more problem on this problem set. Find the second derivative at negative 2, negative 1 for dy dx. So we're starting at dy dx, which is nice, is negative y over x plus y squared. Okay, so this looks like a quotient rule problem where we have to remember the chain rule. So the second derivative is going to be, I'm going to just say negative of this whole thing. Bottom, derivative of the top is dy dx, minus top, which is y. Derivative of the bottom is 1 plus 2y dy dx. Don't forget the chain rule. All over the bottom squared. So x plus y squared. All right, now we got to evaluate this thing. I'm going to need to know what dy dx is at negative 2, negative 1. So just sub in and you get 1 over negative 2 plus 1. So negative 1. So what we're doing is we're evaluating this thing at negative 2, negative 1, and dy dx is negative 1. Here goes. So you just get a lot of 1s or negative 1s because negative 2 plus 1 is negative 1. So x plus y squared is negative 1. Everywhere you have that, you're just getting negative 1. You can go through and substitute everything. I was very unsure of there's so many negative signs, but I'm pretty sure that I got it right in the end. I think. Yeah, I'm pretty confident. I think the answer here is definitely negative 4. It was hard to even find a way to check this. All right, that's the problem set. That's the entire problem set. So I hope this was helpful, and good luck.